So here's the learning target. Determine whether a function given graphically or symbolically is even, odd, or neither. So the first thing we want to do is define these terms. An even function is a function f such that f of x equals f of negative x for every x in the domain. Let's look at an example here. We have f of x equals x squared. And if we look at the inputs 1 and the inputs negative 1, f of 1 equals 1 squared, which is 1. F of negative 1 is a negative 1 squared, which is 1. So f of 1 equals f of negative 1. And let's say we take any arbitrary value c and plug it into the function f of x equals x squared. So f of c equals c squared. And if we look at the negative value of c, f of negative c, we get a negative c squared, which we know that when we square a negative, we get a positive, so we still get c squared. So f of c equals c squared, and f of negative c equals c squared, which implies that we have f of c equals f of negative c. We can conclude that for the function f of x equals x squared, that it is indeed an even function. Now let's look at this graphically. What this is telling me that, for example, 1 gets sent to 1. If we go over to negative 1 also gets sent to 1. 2 gets sent to 4, and negative 2 gets sent to 4. That is, f of 2 equals f of negative 2, f of 1 equals f of negative 1. And what this represents is you can, if you folded this graph along the vertical axis here, it would lie on top of itself. Any even graph is going to have that. So a function is even if and only if its graph is the same as the reflection of its graph through the vertical axis. That means if we folded along this axis, I think you can see that visually, the graph will fold over on top of itself. Now to an odd function. Okay, an odd function is a function such that f of negative x equals negative f of x for every x in the domain. Our example we're going to use here is f of x equals x cubed. Again, let's plug in 1 and negative 1 and see what happens. When we plug in 1, we get 1 cubed is 1. When we plug in negative 1, we get a negative 1 cubed is a negative 1. So f of negative 1 is the negative of f of 1. That is, f of negative 1 equals negative f of 1. So for an arbitrary value c, f of c equals c cubed, and f of negative c is a negative c cubed, which is still always going to be negative, so it's the same as just a negative and then applying the negative to the c cubed. So this implies that f of negative c equals negative f of c. That is, f of negative c equals a negative c cubed, which is a negative of the output of f of c. So we can conclude that f of x equals x cubed is indeed an odd function. What this means graphically is that, for example, 1 gets sent to 1 here, but if we go over here, negative 1 gets sent, it's the same height but in the negative direction. So 2 gets sent to 8, over negative 2 gets sent to negative 8. And what this is called is a function is odd if and only if its graph is the same as the reflection of its graph through the origin. What that means is if you fold over the vertical axis here, f of x, then after you fold over that axis, fold over the horizontal axis here, you will get the graph to lie on itself again. So with the odds, we have to fold 2 times. We fold over the vertical axis and then over the horizontal axis. For an example here, let's determine whether the function f of x equals 1 over x is odd, even, or neither. So let c be an arbitrary element in the domain of f. Then f of c equals 1 over c, and f of negative c equals 1 over negative c, which equals a negative 1 over c. So this implies that f of negative c, which equals a negative 1 over c, equals a negative f of c. And we can say now for sure that f is odd, that the function f of x equals 1 over x is odd. If we look at the graph to confirm it, to see that it is a reflection to the origin, you may have graphed this in your algebra class, I don't know. I think we did when I was teaching the algebra. If not, just graph 1 over x on your calculator and sketch it, and you should get something that looks similar to this. And you can see that if we folded this graph over the horizontal axis and then over the vertical axis and then over the horizontal axis, we would get it to lie on itself. And that is what is going to tell us that f reflects to the origin and f is odd. Next, let's do one by hand. Okay, so our function we want to look at is going to be f of x equals the absolute value of x. We should know that this function f of x equals the absolute value of x can be defined in a piecewise manner as x if x is bigger than or equals 0, and negative x if x is less than 0. So we can graph these. We should easily be able to graph the function f of x equals x and f of x equals negative x. So it's f of x equals x if x is bigger than or equal to 0. So f of x equals x is that, and f of x equals negative x for x less than 0. So that is that. So it looks from our graph here that we have an even function. So therefore, therefore graphically it appears that f of x equals the absolute value of x is even. But we want to check this algebraically as well. I mean, a graph, this is just a hand-drawn graph. We don't know for sure until we check algebraically. So let me pull up a new page here. Okay, so f of x equals the absolute value of x. So let's see be positive. Then f of c equals absolute value of c, which equals c, since c is positive, and f of negative c equals the absolute value of negative c, which equals c. Since c was positive, a negative c, the absolute value of a negative c is the positive number c. So, but we also have to check. This one's a little funny. We have to check these cases. So we also have to let c be negative. So f of c equals the absolute value of c, which equals a negative c. Now think about that. Since c was negative, the absolute value is to negate it to make it positive. This negative c is a positive number since c itself is negative. And f of negative c equals the absolute value of negative c, which is the absolute value of negative c. Negative c is a positive number itself, so it is the negative c. So we see here that in both cases here, and we'd also have to, if c was 0, clearly the absolute value of 0 is equal to the absolute value of 0. But we see in both cases here that f of c equals f of negative c. Therefore, we can show algebraically that f of x equals absolute value of x is indeed an even function. And that's going to conclude this video on the learning target of even and odd functions. Thank you.